Hello mathematicians, thank you for joining me again today as we go through and we try to determine where the function x times x minus 2 cubed is increasing or decreasing and where the extrema are. So now if we want to find where our function is increasing or decreasing and what the critical points are, what we're going to know is that our function is increasing if our derivative is positive, it's decreasing if our derivative is negative, and we're going to have our critical points at the points where my derivative is 0 or undefined and I'm in the domain. So what I need to do is I need to first find my derivative. Now you'll notice that I've written it up here, and so what I would suggest is try to do this one on your own. See if you can get this out after simplification. If you can't though, I would suggest going back over the examples I have for taking derivatives. We go through similar ones like this, where here we're going to have a product rule with a chain rule in it. If you go through step by step and then simplify, we do get out that the derivative is x minus 2 squared times 4x minus 2. So now what we need to do with that though is we need to determine where is it positive, negative, and 0 and undefined. Now what we remember is that, well, the only way we can change from positive to negative is either being 0 or being undefined. So instead of trying to find positive and negative first, we're actually going to find where is a 0 or undefined first. And then we're going to end up making a number line and determining where it's positive or negative. So therefore, where is f prime of x undefined? And so if we look at this function, we notice that, well, we have x minus 2 squared times 4x minus 2 is, well, this is just a polynomial times a polynomial. So this is going to be a polynomial. So what's the domain of a polynomial is, well, the domain of a polynomial is all real numbers. Therefore, where is that undefined? Well, it's never undefined. So we're going to say that f prime of x is undefined never. So the next thing we need to do is find where it's 0. So we're going to set the derivative equal to 0, and we're going to say x minus 2 squared times 4x minus 2 is 0. Notice now that we get a product is 0 if one of the terms is 0. So what we have is either x minus 2 squared is 0 or 4x minus 2 is 0. And so if we continue with this, we can take the square root, we get x minus 2 is 0, so x is 2, or 4x minus 2 is 0 if 4x is 2, so x is 1/2. So now what we have is that my derivative is never undefined, but it is 0 at x equals 2 and x equals 1/2. Now I do want to check to make sure that those are in my domain. Notice that this is a polynomial, so everything's in its domain. So 2 is in the domain, 1/2 is in the domain. So we would say that x equal 2 and x equal 1/2 are the critical values. Now if we want points, we'll have to find the y values, but we know for now at least these are the critical values and we'll find the points later. Alright, now in order to keep track of where my derivative is positive or negative, what I'm going to do is I'm going to draw a number line so that I can keep track of what's going on. It's a nice visual way to keep everything condensed so that we can refer back as needed. Now what we know is that the derivative is only 0 undefined at 1/2 and 2. So these are the only places that my derivative can change from positive to negative. That means that if I look at this interval here, everything in this interval, the derivative is either positive or it's negative. It can't be both, it can't switch between, it has to be exactly 1. So that means that if I check any point in here and find that the derivative is, say, positive, then the derivative has to be positive everywhere in there. If I find that the derivative is negative, then it has to be negative everywhere in there. So what I'm going to do is pick a value less than 1/2. So now I want to pick something easy to calculate. So something that might be easy to calculate is 0. And so what I'm going to find is f prime of 0, because 0 is less than 1/2, it's in this interval, is going to be 0 minus 2 squared is 4 times 0 minus 2 is negative 2. So I get 4 times negative 2 is negative 8. Negative 8 is negative. So the number doesn't actually matter. The only thing I really care about is the fact that it's going to be negative. So we're going to get that on this interval from negative infinity to 1/2. My derivative will always have to be negative because I can't change from positive to negative. Now, If I continue that, I want to pick something between 1/2 and 2. A nice number between there is 1. So if I find f prime of 1, what I'm going to get is 1 minus 2 is negative 1 squared is 1, times 4 times 1 is 4, minus 2 is 2. So 1 times 2 is 2. It's positive. So everywhere in this interval, my function is, or my derivative is positive. Now if I continue with that, I again want to check something bigger than 2. So if I do that, I'm going to check, say, the derivative at the point 3. Now if I plug 3 in, 3 minus 2 is 1, 1 squared is 1. And then I get 4 times 3 is 12, minus 2 is 10. So f prime of 3 is 10, which again is positive. And so what I get is that my derivative is always positive on the interval 2 to infinity. Now that I have my number line here, what I notice is that because the derivative is negative, that means that my function is decreasing. So I'm actually going to draw on a decreasing function. And so my function is going to decrease like that. Now from 1/2 to 2 it's going to increase. So it's going to look something like that. That is, it's getting bigger as we go off to the right. And from 2 to infinity it's going to increase, so it's going to look something like that. Now the reason why I'm doing this is I need to determine if my critical values are going to give me extrema. And so what I look at here is that at 1/2, notice that the function is going to decrease till we get to 1/2 and then increase afterwards. So if we imagine the graph, it's going to decrease and then increase. So what has to happen here is that we have to have a local minimum at the point x equals 1/2. Now if we look at 2, what's going to happen is we're going to increase and then increase some more. So you can imagine that function would look like that. So I increase, then increase some more. So notice that at 2, we're neither going to have a maximum nor a minimum. And so this critical value won't give us a local extrema. So now if we recall, our original question was to find the intervals of increasing and decreasing, our critical points, and our extrema. So what I'm going to do is say, okay, well let's take this and start answering those questions. Where is my function decreasing? Well, f of x is decreasing whenever the derivative is negative. So what we find is that the derivative is negative on the interval, negative infinity to 1/2. So I'm going to say that it's decreasing on the interval, negative infinity to 1/2. Now, where is my function increasing? It is increasing if my derivative is positive. So my derivative is positive on the interval 1/2 to 2. And it is positive on the interval 2 to infinity. So my function is increasing on 1/2 to 2 union 2 to infinity. Now technically, because we have just a zero derivative here at the single point, if it had been more than one point we couldn't do this, but because it's a single point, you can actually just say it is increasing on 1/2 to infinity because it is getting bigger over the entire interval. So now that we have where my function is increasing and decreasing, or the intervals thereof, what we now need to find is the critical points. Now to find the critical points, what we know is that we already have the critical values are at x equals 1/2 and x equals 2. They're both in the domain, the derivative is 0, so we just need to find the points. So what we're going to get is that our critical points are the points corresponding to x equals 1/2, and the y value is f of 1/2, and the x value is 2, the y value is f of 2. So now to find those, all I have to do is plug 1/2 into the original equation, at which point I get 1/2 times 1/2 minus 2 cubed, is 1/2 times negative 3/2 cubed. And so if I cube that, I get 3 cubed is 27, 2 cubed is 8, times 2 is 16. So I get 1/2 comma negative 27 over 16. And then I also get a critical point at 2. And if I plug 2 in, this is easy to calculate. It's 2 times 0 is 0. So my critical points are the points 1/2, negative 27 over 16, and 2, 0. Furthermore, I had to find the extrema, so what I'm going to do is determine if each of these were maxes or mins. Notice that we already said that this was a local minimum, because remember I decreased and increased. And then this was neither a max or a min, so we wouldn't have to label this. So what we've done is we found that my function is decreasing from negative infinity to 1/2, increasing from 1/2 to infinity. I have critical values and critical points at 1/2, negative 27/16, which is a local minimum. And I have a critical point at 2, 0, which is neither a local max nor a min. Thank you for joining me today. I hope you enjoyed it, and I hope you learned something along the way. Make sure to subscribe to the channel and like the video.